Reinforcement learning in robotics and control sounds complex only until you realize it is simply learning through trial, error, and feedback. The same way humans and animals learn skills. Welcome to the Learning Studio, where we don't just teach subjects, we break them down to their core intuition. So you understand why intelligent systems learn, not just how algorithms are defined. Most students think reinforcement learning for robotics and control is purely theoretical or limited to simulations, but in reality, it exists to solve a very practical problem: how to control systems in environments where explicit rules are hard to define. Traditional controllers rely on predefined models, but reinforcement learning allows systems to learn optimal behavior by interacting with their environment. To see this intuitively, think about teaching a child to walk. You don't give equations or instructions. The child tries, fails, adjusts, and improves based on feedback. Reinforcement learning works the same way. A robot takes actions, observes the outcome, receives rewards or penalties, and gradually learns which actions lead to better performance. At a deeper level, reinforcement learning formulates control as a decision-making problem over time. Algorithms learn policies that map observations to actions, optimizing long-term performance rather than short-term responses. This approach is especially powerful for complex nonlinear and dynamic systems where traditional control strategies struggle. On a larger scale, reinforcement learning is used in robotics, autonomous vehicles, drones, industrial automation, and energy management. These systems operate in uncertain environments, and reinforcement learning enables them to adapt, optimize behavior, and handle situations they were not explicitly programmed for. In real engineering practice, reinforcement learning for control is applied when designing adaptive robots, optimizing motion planning, tuning controllers automatically, and improving system performance through experience. Engineers often combine classical control methods with reinforcement learning to ensure safety while gaining adaptability. Now that the intuition behind reinforcement learning for robotics and control is clear, the next step is to explore safe and hybrid learning-based control systems where learning algorithms operate within guaranteed safety boundaries. And that's exactly what we'll cover next here at the Learning Studio.